Okay, this is a presentation of CNCMotion for Portern 9000. You can see here a 3D image of the machine. I can turn it 360 degrees, zoom in, zoom out as you wish. Over here you can see your verify window where you verify your program before running it on the actual machine. The jog control here and the operator panel and the positions. You can see the positions moving while I move the machine. You can see that the machine is behaving just like a real machine. Although it is in simulation, I can press emergency. I can see the report over here on the left. If I double click on the emergency again, report will go away. I can open the door and see a different report. I'm still with the emergency locked. Here we go. So now I have only the door. I can close the door where the door closes and I don't have an error. If I look into the machine, I can scroll up and down. You can see here the tool turret over here with 4 tools. You can see the stock and the chuck. On the other side you can see, hold on, you can see the tailstock. This is representing a real machine. Now if I want to move the machine, I go to the jog control and press Z. I move my Z. Scroll up so you can see from above, and I do X. I move the X-axis. Now for example, if I go and hit the part, I get an impact, which means in the real world, in the real machine, I will break a tool. Here I just get an impact. This impact is because the chuck is not turning. If I will turn the chuck now and I will go and hit, let's have a look, I start cutting. As you see, go out a little bit and I can start cutting if I want to cut. Although the feed is too fast for cutting, I just wanted to show you that if the chuck is not turning and I hit the part, I get an impact, which is for tutorial reasons very good, and not all softwares do that. Now you saw that I can move the lathe, and I can also change tools. If I focus at the tool turret, let's focus at the tool turret here. I'm now going to change the tool to tool number 2. Select tool number 2, I'll move it away so you can see. Now I'm at tool number 2, and if I change to tool number 3, I'm turning the turret to tool number 3. You've got the number as well. I'll go back to tool number 1. You can see it from this angle. Hold on. Here we go. Tool number 1, and it's turning tool number 1. So basically this is behaving just like a real machine. If I will open the door now and I will try to turn on the spindle will not turn because the door is open, again for safety reasons. Spindle can only turn on when the door is closed. Now we moved the machine with the jog control. You can see here when I move the machine, the X and the Z coordinates moving. You can see it here again. Absolute relative machine and distance to go. Distance to go we'll talk about later. What I'm going to do now is I'm going to go to another software and write a little bit of G-code on our software called SpectraCam Turning. This is a CAD utility for turning, which is very simple. Although it is simple, it is giving me all the possibilities I'm doing now freehand drawing. If you don't mind, I'll do an arc here and another arc. Let's go here, and I'll finish with a line going here. So this is our outline. I won't go into this software a lot because this is not our purpose now. This is the rough operation, and now I will do finish operation, and I will save the NC file on my desktop and call it test. And I'll go back to the CNC base software, and I will open from desktop file that I just saved called test.nc. This is the file I just made. Here you can see the G code, which you can either write or get it from another post processor or another software. Now, what we usually do is we first simulate the program. This is done on the verify screen, which I can move. Can make it faster or slower as I wish. This is my part, and if I go to my run and edit screen, I can see the program. And now, before I run the machine, I must home the machine. I'm homing the machine now, and then I will run the machine, and let's have a look at what it's doing. As you see, it is moving already. Scroll up a little bit. Okay, here we go. This is the part, although I already cut a little bit from it just before while I was showing you how to move the machine. Now, before you saw the verify window was working fast, but now I have the actual feed rate, which is shown here. This is my feed rate, rapid, and 203 millimeters per minute. And then you will see rapid in a minute. The bottom, let it finish. It's got, there you go, rapid. He plunges at a different feed rate and goes into this feed rate. I can increase the feed rate just like on an industrial machine, either by +++. Now the feed rate is going faster, okay, and decrease it. And I can also increase the spindle speed, the override, increase the spindle rotation speed up and down. I can pause the program, play or stop the program. I can run it single line, single step, optional stop or optional skip, just like an industrial machine. All the G codes lines are seen over here, and as you see, you can see the part time. It's taking me almost 2 minutes to make about 3/4 of the part. Let's wait until it's finished. I reckon it will be 2 minutes 40, something like this. Now this is important because if you want to produce a lot of parts, you can see the part time before you actually go to the machine, where you can do calculations if it's feasible, if it's making you money or losing you money. Again, all this is done in the simulation software. This is a simulation of the proton. Now it's going to do the finish cut. No, that's the cut before the finish cut. Here we go, that's the finish cut. As you can see, the finish cut, he changed the spindle speed to 2500, chuck is turning faster, so the groove is much smoother. And in a minute, here we go, it's finished now, which took it 3 minutes and 3 seconds. So I was wrong, and maybe I'm losing money now, because I thought my part would be 2 minutes 40 seconds. So again, verify. Here is your G-code and 3D image, and all your windows are over here. Thank you. Another option, if I go to Window and click on Fanuc screen, I can see my simulation software, and I changed to a real Fanuc simulation software. Now this is your basic Fanuc touchpad. You can go into Program. This is my program. You can go into your position, absolute, relative, or all. You can go into your offsets and your graphs and so on and so on and so on, and still stay with the simulation of the machine. Again, if I go into, I need to home the machine, home X and Z, but this is not important for now. I can run a simulation of this part program. This is my program, blah, blah, Hold on, this is not the program that I wanted, but doesn't matter. I can go back to IntelliTech screen or Fanuc screen, just like a click of the button. This is it for now. The advantages of this software is you are having a simulation of an industrial machine where you have a lot of PCs in your lab, and let's say 1 machine or 2 machines and 20 students. You cannot have 20 machines. You will have 2 machines, and the simulation software will be running on all PCs. This way you can teach a whole class instead of 2 at a time next to the machine. Now this machine can cut various material up to mild steel. It's an industrial machine, industrial grade machine. It's got coolant, and using this software gives you the benefit of having a simulation of a real machine in the class, getting all your problems, all your errors with the students on the simulation software. Once he gets to the machine, he's familiarized with the actual machine. If the machine is in another lab, he can go to the lab and say, oh, this is the machine I worked on before in simulation.